Okay guys, remember we did this one in class. Let's go over this real quick. Remember, new thing says that let's grab a pen real quick over here. That's brush. I want to hit a pen. Here we go. Let's change that color to black. Good. Remember, the new thing today says that you got to deal with the work function, which says the energy of a photon is equal to the maximum kinetic energy plus your work function. Remember, work function is equal to Planck's constant times the threshold frequency. We'll use that in just a second. If you solve this for the phi, you get EP minus kinetic energy. Then if you solve that for the phi, you know EP is HF minus KE, since they gave it to us. You know phi is equal to HC over lambda minus KE, because if you notice right here, the wavelength, they gave us a wavelength, so you had to make sure you put in the C. Now you know phi is equal to H, which is 6.63 times 10 to the minus 34. And that tells me also that I have 3 times 10 to the 8 over lambda, which is 350 times 10 to the minus 9. Now, since this kinetic energy is in EVs, we have to go ahead and hit this guy. You know 1 EV is equal to 1.6 times 10 to the minus 19, close it, minus the KE, which is 1.3 electron volts. After you do all that calculations, throw it in the calculator, then you know that your answer should be, give me a second, do my little handy dandy calculator. I get 2.25 EVs. Okay, so that's problem number 1. Now let's keep working here. Let's get us a new page. Let's see if it's going to let me give me a new page, or do I got to save this? Save as. We're going to hit this guy as, put in the right folder, atomic physics. We're going to call this one problem 1. Save. Still not quite finished, because now we've got to go back and find the threshold frequency. If you recall that B says threshold frequency phi is equal to HFT, which implies that FT is equal to phi over H. So now you know FT is equal to 2.25. Be careful, gotta convert this back to joules, which is 2.25. My frequency, my H is 6.63 times 10 to the minus 34 times right here 1.6 times 10 to the minus 19. I know that got a little messy, but I had to sneak it in there so you can see where we were going. Therefore, your threshold frequency turns out to be 5.43 times 10 to the 14 hertz. While I'm here, I'm going to go back and go ahead and clear the page, because now the next part says, what is the wavelength of the least energetic photons? Well, since you know the frequency, you know c, speed of light, is equal to f times lambda. Therefore, lambda is equal to c over f. Since you found the threshold frequency, that's going to give you the wavelength. That becomes 3 times 10 to the 8th over 1.6 times 10 to the minus 34 times 10 to the 8th over 1.6 times 10 to the minus 34 times 10 to the 8th over 1.6 times 10 to the minus 34 times 10 to the 8th over 1.6 times 10 to the minus 34 times 10 to the 8th over 1.6 times 10 to the minus 34 times 10 to the 8th over 1.6 times 10 to the minus 34 times 10 to the 8th over 1.6 times 10 to the minus 34 times 10 to the 8th over 1.6 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 times 5.43 times 10 to the 14th. Therefore, my lambda turns out to be 552 nanometers. Right? Recall, nano is 10 to the minus 9th. Problem number 1, atomic physics, photoelectric effect. Let's go ahead and save this. File, save.